Smoking cigarettes in bed can cause fires, often with fatal consequences. In Dornbirn, Austria, researchers from the University of Innsbruck are developing textiles that do not ignite and can therefore save lives. The prototype of a bed linen could be realized after several years of research.
Smoking
is still practiced in many nursing homes, and sometimes a resident falls asleep while smoking a cigarette, and the glowing ashes drop onto their bed linen or an item of clothing. When this happens, the person's ability to react is sometimes not as good, and the item of clothing or the bed linen catches fire. The special feature of the textile product that we have developed here is that the embers simply die away. There is no flammability at all. After a very short time, the embers that could be caused by the cigarette simply go out.
The basis of the textiles is a viscous fibre into which silica is incorporated. The silicon dioxide is responsible for the flame-retardant properties. Non-burning textiles already exist, but the chemicals used are often toxic. Silica, on the other hand, is safe.
As the flammability has a mechanism, you need heat. So without heat, there is no flame. Then you need air, and then you need a fuel. And if you have enough of a heat and then it starts, a flame ignites, then it needs more fuel to continue, and it also needs air. If any one of this is stopped, then there is a chance of the flame not propagating, and propagation is the biggest problem. So there are some flame retardants which act as a heat sink. It basically absorbs the heat, so therefore your burnable or the flammable material does not reach burning temperature. The second is it creates a foam and acts as a physical barrier between the air and the solid. These are called intumescent coating. Then there are others which say that I will not allow volatiles or flammables to be generated, and they create char. Char is this carbonaceous material which forms on the surface and simply says I'm not going to burn anymore, and silica does the charring.
The Research Institute of Textile Chemistry and Textile Physics cooperates with various companies from the textile industry in Dornbirn and beyond. One of these companies from Germany has developed the special fibre and thus provided the idea for flame-retardant bed linen.
It all started when a company, Kelheim Fibers from Germany, introduced us to this fibre. We immediately wanted to implement the idea of developing a product from this material. The problem was, or rather the difficulty was, maintaining the properties of the fibre over the entire production chain, making sure that the silica, which was integrated into the viscose fibre, would be retained throughout so that it would sustain all processes, from washing, bleaching, dyeing and finishing. And also the finished product. This would be used regularly and washed over and over. The durability of the reduced flammability must be guaranteed, and this is what we have tested here. We tested formulas, we tested the fire's behaviour, we tested the glow residue, and these parameters showed us to what extent our ideas were right, our formulas were right. And then everything was implemented.
Unsere Rezepte richtig waren und das wurde dann alles umgesetzt, ja.
Spinning the fibres into a suitable yarn and further processing in the weaving mill are the first challenges in the production of the special bed linen. Industrial dyeing of the fabric, however, poses particularly great challenges for the scientists because it must be ensured that the silica is not dissolved from the fibre.
There are some standard dyeing procedures. One of them is called reactive dyeing, and it has certain pH ranges, certain times and temperatures. And then when they first did the trial on the fiber, then they found that there was a deposit on the vessel, and deposits on vessels and things are problematic because the company then has to spend time cleaning, 100-liter vessels thoroughly. So all of this has to be avoided. So then they did lab trials here. They did a series of changes to the dye bath composition, minor changes so that the dyeing is not affected. But that stops the silica from dissolving out of the fiber and being lost from the fiber.
The knowledge gained from the experiments can be used to optimize the industrial dyeing processes in such a way that no more silica is released from the fiber. The fire behavior of the fabric is also being investigated. The practical test shows clear differences. While conventional fabric continues to glow, the embers in the flame-retardant fabric do not spread further. The silica content can be quantified in the laboratory by means of a separate flame test.
Then we measured the time until the sample started to burn, for example after 5 seconds, whether it ignites or what the exact trace of the flame or fire is. This should be relatively small. We then compared the results with the reference material. While we were developing the formula, we investigated the fire's behavior and the residue on ignition. Samples from the dyed samples were then burned and then the residual ash was measured. This was an indicator of how much of the silica was left or of the formula itself.
The suitability of the bed linen for everyday use is currently being tested, as colour and flame retardant properties must be retained even after repeated washing. The scientists in Dornbirn are already thinking ahead and are currently working on using the fabric for flame retardant clothing.